Hello to you. My name is Jesse Johnson. This is Permanent Magnets, Alternative Energy, a working semi-perpetual machine. The Johnson Self-Climbing Machine, or JSCM. This is to produce 250 billion, that's with a B, billion watts per day or more. Invention is freely given to the whole world. Please translate this video into every language for every country, especially poor countries. Share and spread worldwide. There are two types of machines, initiator and non-initiator. Initiator runs some of the energy produced back into the initiator to keep the machine going. No external energy needed. Go to the 5 links below this video. Now, drawings for this machine is a semi-perpetual machine mainly to produce electricity. The 4 laws of thermodynamics. Number 1, 2 or more systems with same temperature have thermodynamic equilibrium. Number 2, a bounded space where no energy exits or enters. The energy is quantitatively conserved. Number 3, there are 2 entropies, entropy and anti-entropy. A bounded space where no energy enters or exits, there's overwhelming physical tendency for order to become disorder and increase. B, in indefinitely open space where energy enters and exits, there's overwhelming physical tendency for anti-entropy of disorder to become ordered and to increase. Now, number 4. It is impossible to reach the temperature of absolute zero in a finite number of steps. There are 15 to 20 laws to machines. 2 of those. 1, all machines are made of something. Number 2, all machines are compositions. All compositions decompose. Perpetual over unity, free energy machines are impossible. But semi-perpetual machines are possible and can be built with long-lasting work output over weeks, months, or years. This particular semi-perpetual machine is basic physics, basic machinery, and basic mechanics. System uses 3 fields: electric, permanent magnets, Earth's force field. That's the EFF. Now go to the 5 links below this video and learn of these principles. I'm going to move the camera. Hold on, please. To continue, this machine is about alternative energy systems. Alternative energy systems. Now, this is how to construct and make a working semi-perpetual machine. This is the Johnson Self-Climbing Machine, or the JSCM. This is by Jesse Johnson, the semi-perpetual self-climbing machine. This is to produce electricity of 125 and more billions. Giga is billions, 125 billion watts per day and over. This is a power plant. This is to turn electric generators. It is an alternative energy system. Now, these are a few of the machine's benefits. This answers the question, what's in it for me and what is it good for? 1, makeable any physical size from 100 pounds to 1,000 tons, dead weight units and over. 2, very long-lasting, several years to several dozens of years of extra work output. Number 3, easy to fix. Number 4, made of very common materials. Number 5, compact and takes less space. Number 6, uses most basic physics of machines and mechanics. Number 7, it is non-polluting, 99.999% pollution-free. Number 8, it is low cost in comparison to other methods of turning force to turn electric generators. Number 9, it is very, very low cost maintenance. Number 10, it is single resident size to industrial mass level size to nation mass level sizes of usage. Number 11, turning force force of semi-perpetual machine is connected to electric generators. Number 12, the largest type of these systems is able to produce 92 trillion, that's Trillion, produce 92 trillion watts per year as 1 unit or more. To continue with benefits. Number 14, this system is capable and able to outperform hydroelectric, wind, solar, photovoltaic, natural gas, coal, oil shale, tars, ocean tide, geothermal, biomass, biogas, etc. combined. Number 15, very simple in concept and construction in comparison to other methods. Number 16, 99% free, F-R-E-E, 99% free energy. That means 1% is you must build the system and maintain the system and the infrastructure for it. To continue, hold on please. Now, your help is needed in this matter. Please, your help is needed in this, please. Number 1, share this semi-perpetual machine with all countries. Please use your own online systems. Number 2, please use free publicity in sharing this system. Number 3, use your Reddit and subreddit accounts if you have them. Number 4, if you already have a blog, please discuss this machine with the mechanically minded and the environmentally minded. Number 5, if you are clean energy minded, please make sure that the right people see this video on industrial alternative energy systems. Number 7, please put into alternative energy journals, energy magazines, publicity online. Number 8, download this video and put it on other video platforms. Hold on, please. Now, let's continue. This is illustration A, hydroelectric production, which is the principle this machine is based on. Water on a table at position A falls down in direction B and accumulates at position C. While falling, the water turns turbine fan blades of a turbine. The turbine is connected to an electric generator over here, which produces electricity which goes through the system to your house. Here's a physics principle. The force to make the water fall down from A to C is the same amount of force which is equal to the amount of force that it takes to take the water back up from C all the way back up to A along the red line. The problem to solve in this case is to do this same thing with solid systems instead of with liquid water. The machine falls, climbs, etc. repeatedly and indefinitely. Hold on, please. Now, this is illustration B. This is how electrical power in watts, this is how much electrical power in watts, 555 tons falling per second, per day, and per year can be produced. The greater the dead weight, the greater the watts produced. HP equals horsepower, D equals day, W equals watts, G equals billion. Number 1 horsepower equals 550 pounds per feet per second. 1 horsepower equals 746 watts per second. Number 2, 1 horsepower per day equals 746 watts times 86,400 seconds, which is 1 day, which equals 64,454,400 watts a day. Number 3, 4 horsepower per day equals 4 times 64,454,400, which equals 257,817,600 watts a day. Number 4, 100 times 257,817,600 equals 25,718,760 800,000 watts a day. That's equal to approximately 25.7 gigawatts, or 25.7 billion watts a day. We'll go to number 5. 5 times that even. 5 times 25,718,760,000 equals 125,908,800,000 watts per day, which equals about 126 gigawatts a day, or billions of watts per day. We'll go to number 6. 126 gigawatts, or billion watts, 126 billion watts equals 555 tons gross, falling per second times 86,400 seconds, which equals 1 day, of course. We'll continue. 1 horsepower equals 555 pounds. Pardon me. Yes, that's correct. 1 horsepower equals 555 pounds falling per second times 86,400 seconds, which equals 1 day, which equals 64,454,400 watts per day times 365 days, which equals 23,525,856,000 watts a year. Now we'll go to 500, this one, number 2 here, and that is 555 tons, 555 tons falling per second times 86,400 seconds, which equals 1 day, equals 125,908,800,000 watts per day times 365 days, which equals 46 trillion watts per year. We'll go to down here to the bottom, number 3. 1,025 tons, 1,025 tons falling per second times 86,400 seconds, which equals 1 day, equals 251,817,600,000 watts per day times 365 days equals 92 trillion watts per year. Now we'll continue. Hold on, please. Now your help, once again, your help is needed in this matter, please. Number 9, if you are electrical engineers, students of electricity and magnetism, spread this knowledge to your university departments, colleges, and schools. Number 10, please make known to energy foundations of the existence of a working over 95% free energy alternative energy system. Number 11, should you have Facebook, Twitter, Reddit accounts, please share with all environmentally minded and clean energy minded. Number 12, please let all associates, teachers of near free alternative energy at nation levels that this machine exists. Number 13, share this working semi-perpetual machine with your blogs, friends, and audiences. Number 14, if you speak a language other than English, download this video, put it in another language, please. Hold on, please. Now, this machine is made of 3 main parts. 1, 2 or more dead weights, a frame for the dead weights to climb up on after they fall, and a slide magnet cage for the system's operation. Please hold on. This is a side view. This is illustration D. A majority of physics principles, a major physics principle of this machine is permanent magnetic field balancing, done by, A major physics principle of this machine is perpetual magnetic field balancing, done by putting a piece of common highly magnetizable metal of an exact thickness, exact width, exact length in the exact middle of 2 magnets of exacting dimensions that are repelling each other north-north or south-south, but are attracted to the metal with equal but opposing force. The fields balance and the directions of the magnets are canceled. In other words, repulsion of the magnets, magnet A and magnet B, is attracted to the metal, but they're repelling each other, and the repulsion of the magnets to each other equal the attraction of the magnets to the metal, which is field balance. Hold on, please. These here are the parts of the machine. The parts of the machine. 1, cage racket. 2, initiator. 3, field balancing metals. 4, slide magnet cage. 5, magnet 5. 6, frame. 7, pulley. 8, wheels. 9, handle brace. 10, handle lift. 11, handle. 12, counterweight. 13, ratchet. 21, pin. 14, counterweight table. 15, counterweight rail. 16, frame rack gear. 17, floor. 18, pad. 19, rack gear. 20, ratchet. 21, ratchet. 22, magnet. 22, 23, spring. 24, cage halter. 25, magnet. 26, field balance metal. 27, cord. 28, dead weight. 29, magnet 5, jacket. 30, 10 to 11 cord. 31, time pins. 32, rise and fall start pins. 33, initiators batteries, and positions A through H right here. Please hold on. We will continue. Now, this here is illustration F. This is a front view of the machine and how the system works when climbing so that it may fall again repeatedly, indefinitely. Climb up to the top and fall repeatedly, indefinitely. Up, down, and fall. We will start with the operational. The operational here. We will start here with number 1. The counterweight, number 12. Number 12. The counterweight, number 12 here, is at position H. Here. Pressing down ratchet 21 pin, number 13, which is here, which is at position E. The handle, number 11, is at position E. The bottom of the dead weight, 28 is the dead weight, is at position F, right here. Number is right here at F. On top of the pad, number 18, in blue. Magnet 22 here is at position D. And bottom of slide magnet cage, this is the slide magnet cage, which is number 4, is at position G. Magnet number 5, which is here, is at position A. Ratchet 21 is at position. Ratchet 21 is here, is at position, is pushed back into dead weight 28 right here, which is at position C. This begins the process of climbing. Number 2, magnet 22 attracts to the underside of the field balancing metal, number 3, which is in blue here. This picks up the dead weight 28, the dead weight, which is attached to magnet 22. Handle lift number 10, right here, handle lift number 10, is attached to the dead weight 28, is also attached by 10 to 11 cord number 30, right here, and which itself is attached to handle 11, right here. All go up simultaneously. As dead weight 28 goes up, handle lift 10 goes up and pulls handle 11 up. Pulls handle 11 up by here. Right up in here, it pulls it up, number 30, pulls the handle up, which pulls up the counterweight number 12, which picks up counterweight number 12 by its core 27 segment, which is right here, right up in here, right here, and which is tied to the handle lift 10 and handle 11. When counterweight 12 is high enough, it lets ratchet 21 pin number 13, which is here again, number 13, become completely extended, of which ratchet 21 pin number 13 is coupled to counterweight table, which is right here, number 14. 14, of which is attached to dead weight number 28, of course. And ratchet 21 pin, number 13, by the mechanisms, is coupled to ratchet 21. From here, up in here, all the way up here, and to pull it backwards from being meshed with frame rack gear 16 teeth to start upward climb of total system. We'll go to number 3 here. Now the counterweight 12 is here, moves stably up and down counterweight rail number 15 up here. This is the rail right here, number 15. For linear control when things are in operation mode. As dead weight 28 goes up, this compresses the springs number 23. Dead weight 28 cannot fall downward because of the ratchet number 20. Ratchet number 20 is here. It cannot fall down. You have ratchets all down here, all along here, making the dead weight not able to fall down. A handle number 11 is held in place stably by handle brace 9, which is turned, which in turn is held stably by pulley number 7 system, pulley right here, and which itself is attached to slide magnet cage. The slide magnet cage is attached to the slide magnet cage here. Now, the weight of dead weight 28, weight pull slide magnet cage number 4 right here, slide magnet cage, number 4 downward, wind going up. And slide magnet cage number 4 cannot fall because its cage ratchet number 1, its own cage ratchets, which is also able to hold up dead weight 28's weight. Now number 4, while dead weight 21 goes up, it is able to climb frame number 6. Frame number 6 is, this is frame number 6. Frame number 6, able to climb frame number 6. Several inches at a time, using frame rack gears 16's teeth. This is the frame rack gears teeth, right here, 16's teeth. Now, as magnet 22 goes up, its surface stops at 1/100th of an inch from the surface of the field balancing metal, right here. Stops. It does not touch. They do not make contact or touch. Between magnet 22 and magnet 25 is field balance metal 26, and between magnet number 5 and magnet number 25 is field balance metal number 3. This balances the fields of these magnets to 0 when in operation. When magnet 22 comes to a stop, indicator number 2, initiator number 2 instantly, here's initiator number 2, instantly comes on and it pulls magnet number 5 to position B, pulls it across here to position B. And this will be above and over magnet 22 with field balancing metal 3 exactly in the middle between them. Magnet number 5 surface is also 1/100th of an inch from the surface of field balancing metal number 3. This balances the magnet's fields to 0. If neodymium magnets weigh 100 pounds each, initiator need about 5 pounds of pulling force to pull it from A to B. Now we'll go to number 5. To break magnet 22's magnetic field strength, pull hole on balancing metal number 3, field balancing is needed. Otherwise system can't work. Magnet 22's magnetic field hold on field balance metal number 3 is reduced to 0 and now can be moved away. Once magnet number 5 is at position B, spring number 23 is unlatched and decompresses and pushes slide magnet cage number 4 up. Pushes slide magnet cage up with these springs. Pushes it up. Slide magnet cage goes up and is halted by cage halter number 24. That's right here. Number 24. And this separates magnet 22 and slide magnet cage 4 once again. Once slide magnet cage 4 reaches position G, once again it reaches position G, above dead weight 28 and magnet 22 again at position D, ratchet 21 is instantly released to mesh again with teeth of the frame. Rack gear 16 by its time pin along the frame number 6. This keeps dead weight 28 from going up until the right time. Initiator number 2 is shut off and counterweight number 12 is released and falls and pulls magnet number 5 horizontally over field from B back to A as counterweight falls. Initiator number 2 is shut off and counterweight number 12 is released and falls and pulls magnet number 5 horizontally over field balancing metal number 3, pulls it backwards, and 3 is surfaced by using the little wheels and back to position A by using cord number 27. Here's the little wheels. You see these little round things in the blue? That's the wheels that the magnet slides over. Now we'll go to number 6. Counterweight 12, that's over here again, falls and compresses ratchet 21 pin number 13, right here again, and this pulls ratchet 21 inward away from the frame rack gears 16 back to position C, right back to position C again, to C again, and the simple process is repeated until dead weight 28 climbs and reaches top of frame 6. When slide magnet cage 4 and dead weight 28 reach top of frame 6 simultaneously, both slide magnet cage and dead weight 28 contacts time pins 31, time pins all along the rail, as time pins all along the rail, time pin all along the rail, contact pin 31 attached to frame 6, which unmeshes cage, slide magnet cage, and dead weight, which unmeshes the cage, ratchet 1, ratchet 20, and ratchet 21 from the frame rack gear 16 teeth, and total slide magnet cage 4 and dead weight 28 fall freely downward toward bottom of frame 6 to pad number 18, which cushions it. This takes 1 second. Now, regardless of how much pounds or tons dead weight 28 weighs, the amount of time in seconds the dead weight 28 takes to get to the top of the frame from the bottom is the amount of dead weights themselves in the system. 1 dead weight per second falls. When dead weight 28 get to the bottom, it instantly starts to climb. Let's continue, please. This is illustration G. This is a side view of the machine. This here are the sleeves of the magnet of which the little wheels roll on. The little wheels roll on this. They do not roll on the magnets. This is a side view of the machine. This is the dead weight. This is the number 13 pin. This is the handle. This is the pulley. These are magnet 22. This is magnet 25, and so forth and so on. Let's continue, please. Now, this is illustration H, an oblique view of the dead weight. This is an oblique view of the dead weight. 100 magnets each. You have 1, 2, all the way to 10, all the way to 100 magnets each. Each magnet has 10-ton force, a 10-ton pull force, each magnet. These are neodymium permanent magnets. They are dead weight magnets, and the dead weight is 560 tons of dead weight. It could be made of cement, plated steel, it could be made of anything as long as it's dead weight. The greater the dead weight, the more magnets needed. This right here is the electric generator drive shaft. This rack right here, this rack of gears, turns this drive shaft of the electric generator. Hold on, please. Now let's continue. This here The number of seconds to reach the top of the frame, like this one here, number 1 is down at the bottom. The number of seconds it takes for number 1 to reach the top of the frame is equal to the number of dead weights in the system. Number of dead weights in the system. Here's an example. Number 1 right here takes 1 second to fall to the bottom from the top. Number 2, it takes 8 seconds to reach the top from the bottom. Number 3, number 1 presses number 32, which is right here. Number 32, which is the timing pin, presses number 32 when reaching the bottom, then starts climbing. Simultaneous, number 2 starts to fall. Number 2 falls now. Number 2 falls. Number 2 reaches bottom and presses its own number 32 and starts to climb also. At the same time, number 3 starts to fall. Process reaches 9, which is number 9 of the dead weights, and continues to repeat. Number 1 falls, hit its number 32, this one starts to fall. This one, simultaneously, when it hits its number 32, it starts to climb. This one here falls, it starts to climb, but this one starts to fall. When it hits its 32, this one starts to fall, but it instantly starts to climb, etc. Let's continue. This is a front view of of this system. Number 33 is the number 2 is battery. You have an initiator. All of these have initiators in it, and the initiator takes perhaps about a half a horsepower, fourth of a horsepower, whatever it takes to pull 10 to 100 pounds of magnet across a level. Once again, your help is needed in this matter. And here's number 15. Contact all alternative energy companies and tell them of this video on YouTube and elsewhere. Number 16. If you understand open source and you know how to do it, then please put this video on open source. I want to thank everyone for listening and watching, and please have a very good day.